Today, I will explain the concept of spectrum, that how atoms give us the electromagnetic spectrum. Uh, and after the clear concept of the spectrum, I will explain how the hydrogen spectrum is formed, specifically the Lemon series, the Balmer series, Paston series, Brackett series, and Puffin series are formed by the hydrogen atom. So, moving forward, first of all, the dispersion of white light. We know that white light is made up of all the colors of the visible spectrum. So, passing is it through a prism. Basically, what prism does, prism spreads it. Now you can see clearly a white light after passing through the prism, due to the refraction process. All the components of the white light are basically they are spreading out. So what we get after this, when we just output of this spectrum, so we get this kind of output on the photographic plate. So you can see all the bands of colors are there. So basically it contains no gaps, no boundary, or no boundary between different bands of color. You can see there is no boundary, all the colors are merged together. And secondly, it contains all the wavelength of the light in a certain range. So this spectrum must be a specific identification. So we identify this type of spectrum as continuous spectrum. Moving forward, if the light is not white, so how we get this light? Basically we can get by heating a gas, or with electricity we can get it give off the colors. So when we pass, or passing this light through a prism does something different. So what kind of different we see? We see this kind of difference. Now this is the spectrum of hydrogen gas, and this one is the spectrum of helium gas. Basically we just when we give the energy to the hydrogen or helium, after absorbing the energy, hydrogen give us this kind of spectrum and helium give us this kind of spectrum. So now let's talk about the characteristics of this spectrum. Basically it contains huge gap between different bands of color. You can see that there is a huge gap between this red line and the green line, and even between the green line and the blue lines. And secondly, it contains few wavelength of the light in a certain range. So this spectrum is different than the previous one. I have already shown that the previous name was continuous spectrum, but we call this type of spectrum as a line spectrum. Okay, now let's talk about so how atom just give us this kind of spectrum. Just let's talk about the concept of this. Basically we can also call this how we get the line emission spectrum. Basically it has a specific name also, that is emission spectrum. So I will just explain you what is emission as well. Okay, let's suppose we have an atom in a ground state. When we just give energy, so the ground state become excited state, but it does not remain in the excited state forever. So it basically came back to the ground state after releasing photons. Photons mean the light basically. And just releasing the photons or light, we just pass it through the prism and we get this kind of spectrum. And this is the just flow chart or diagram flow chart, we can how we get this spectrum. Okay, moving forward, now let's talk about in detail what is the difference between the line emission spectrum and the absorption. Let's suppose we have a hot source, and if we just hot source basically give us the all the visible light spectrum of all the colors. Basically when we just pass this light through the prism, we always get the continuous spectrum. But let's suppose we have a gas, any specific element, and when we pass the light of the hot source from that gas, so gas will absorb a certain amount of energy and it will become excited, but the rest of the energy will pass through the gas. So when the rest of the light will pass through the gas, and if we just pass it through the prism, so we will get a spectrum with all the colors are there but some colors are missing. So this kind of spectrum is called absorption spectrum basically, or we can also call this as line absorption spectrum. Okay, now you can see the gas is excited, it will not remain excited, so it will just release or emit uh, the photons after going back to the ground states. So when it emit the light, so and when we just pass this light through the prism, and then we will get this kind of spectrum that is called emission spectrum, or we can call the line emission spectrum. Now this is the difference between the absorption spectrum and the emission spectrum. So now you must have the clear idea the what is the difference between the line absorption spectrum and the emission spectrum. Okay, moving forward, now let's talk about the hydrogen, how hydrogen spectrum is formed. Basically, right now, let's suppose we have a range of all the electromagnetic spectrum. Uh, the the lowest you can see, basically, I just showing this diagram that the which has the lowest wavelength, it is on the bottom, and the which has the highest wavelength or the longest wavelength, it has top. Okay, now let's suppose we have a nucleus here, and when the uh, atom in the excited state, so the electrons are at the higher energy level, so there is a possibility that electron are basically jumping from higher state to the first energy level. So it can come from the second to first, third to first, fourth to first, fifth to first, and so on. It can come from any of the higher energy level to the first. Now remember that the first, basically, this kind of spectrum was recorded by the Lemon in the energy of ultraviolet region, and it was recorded by the Lemon. So the because of the Lemon discovery, it was named as Lemon series. Moving forward, now there is another possibility that electron is coming from higher energy state to the second energy level. So all the possibility, if we just move to third to second, or fourth to second, fifth to second, and so on, so there is another possibility we will get a spectrum of energy. So this was observed in a practical manner, that the light emitted by these electron was in the range of visible light, and this was discovered by the Balmer, so we call this as a Balmer series. Moving forward, there is another possibility that electron are coming from higher to third energy level. So this was discovered in the infrared region, and this was discovered by the Paston. So we this was later named as Paston series. And there is another possibility that the electron are coming to the fourth shell or fourth orbit from the higher energy level. So this was also discovered in the infrared region, the middle, we can say the middle part of the infrared region, and it was discovered at the bracket. So we call this as a bracket series. And in the last but not the least, uh, another spectrum also formed or basically observed practically in the infrared region. That was the electron are coming from higher energy level to the fifth orbit, and this was discovered by the Pufend. So we call this as a Pufend series. Okay, how we can remember these series, that how the hydrogen atom give these series. The very shortcut answer is this, that if we just remember one thing here, that the electron when the electron are coming from higher energy level to the first energy level, so we can call that n1 will be equal to, when the n1 is equal to 1, then we will get the Lemon series. When the n1 means our lower energy level is 2, then we will get Balmer series. When the lower energy level will equal to 3, then we will get Paston series. And then when the lower energy level n1 equal to 4, then we will get bracket series. And when we the lower energy level will equal to 5, then we will get preference series. So that's all. If you have any question, you can ask in the comments. Thank you.